Hello, welcome to Engineers Mindset. Now I'm going to take you through a series on how to differentiate partially trigonometric functions from formula method. Now I'll show you two ways. I'll show you the normal way and I'll also show you a shortcut approach to it. Let's say I have z equal to cos xy and I'm asked to find the partial derivative of z with respect to x and also partial derivative of z with respect to y. Now I'll take you to the normal procedure. We have z equal to cos xy. So let's say let u be equal to xy. It now simply implies now that z is equal to simply cos u. Because I'm saying in place of xy, simply put in the value as what? U. So this means now that z is a function of u, meanwhile u is a function of x and y. So z now depends on the value of u to be defined. So whatever value I give you, that is what z depends on. Okay? Meanwhile, x here is u here is simply a function of x and y because u depends on the value of x and y. And here, z is simply a function of what? Only u, because z depends on u. So that means the partial derivative of z is going to be with respect to u from here. So I will have that partial z, partial u, because I'm differentiating now, z is going to now change with respect to u, because z is no longer a function of x and y. Okay, so partial z, partial u is simply equal to, if I differentiate cos u, I will simply have minus sine u. So that's what partial z, partial u is. But from u is equal to x, y, I cannot find the partial derivative of u with respect to x. Because the question says I should find first partial z, partial x. So that's what we're looking at. Okay, so partial u, partial x is now equal to, I said, if you're differentiating u with respect to x from formula method, it means I'm going to treat y as constant. So keep y as constant. Remember, this x simply means x. When you have u equal to xy, it simply means that u is equal to x to the power of 1, y is to the power of 1. So their power is actually 1. Okay, so you see them as saying x and y, their power is actually 1. So I'm keeping y constant, then I will differentiate x. Use the power of x to multiply the value of x. The power of x is simply 1 times x. Then subtract 1 from the power of x. So I'll have 1 minus 1. Okay, so I'm simply going to have this. So it means that partial u, partial x is now equal to y times x. 1 times x remains x. 1 minus 1 is 0. Okay, so I said that any variable or any number apart from 0 raised to the power of 0 is simply 1. So x raised to the power of 0 is 1. So that simply means now that, okay, this is simply y times 1. So partial derivative of u with respect to x is simply y. But this is not what the question says. The question says you should find the partial derivative of z with respect to x. So partial z, partial x can be gotten from chain rule of differentiation, chain rule of partial derivative. And that chain rule is simply first partial z, partial u times partial u, partial x. So notice that partial u and slight partial u, we are left with partial z all over partial x, which is what the question is asking us to find. Okay, so partial z, partial x is now equal to partial z, partial u give us minus sine u. So we have minus sine u times partial u, partial x give us simply y. So we have times y. Okay, so that simply implies that partial z, partial x is simply minus y sine u. But recall, we said u is simply what? Xy. From here, we put u as xy. So that simply means that partial z, partial x is simply minus y sine xy. Alright, so that's how you find from formula method. This is the normal method of approach. Now I'm going to show you the shortcut to it. This is the shortcut. I have that z is equal to cos x, y. And I'm asked to find partial z, partial x. Now, this is what I will do. Partial z, partial x is now equal to, first of all, I will differentiate the angle. The angle is simply xy. So I will differentiate the angle xy with respect to x. So remember that if I'm differentiating xy with respect to x, let's say I have xy, I'm differentiating xy with respect to x, I will simply keep y constant. I will treat y as constant, then I will differentiate x. This is x to the power 1, which is simply 1 times x raised to the power 1 minus 1. And this is simply what? 1 times x raised to the power 0, which is also y. So differentiate the angle first. If I differentiate the angle, I will simply have y. Use that y to multiply the derivative of the three function itself. If I differentiate cos, cos will simply give me minus sine x, y. So this is simply saying partial z, partial x is simply minus y sine x, y, which is still the same thing I got from the normal method. So here is the check. Differentiate the angle first, partially with respect to y, and then differentiate the trig function, which is cos. That's it. Now let's try the second one. The second one says we should find partial z, partial y. Okay, so we have z equal to cos, z equal to cos x, y, and we are to find partial z, partial y. Okay, so see the same thing. Let u be equal to x, y. If u is x, y, it means now that z is actually cos u. So z is now a function of u. Therefore, the partial derivative of z with respect to u is now going to give us minus sine u. So you have this. Okay. Alright, so you have this. Okay, let's now differentiate u from u equal to x, y. Since the equation says find partial z, partial y, it means now we are going to differentiate z, u with respect to y, keeping x as constant. Therefore, partial u, partial y is now equal to keep x as constant. X is held constant. This y simply means y is the power of 1. So use the power to multiply y. I will have 1 times y. Then remove 1 from the power. So I'll simply have 1 minus 1. This is this. And this is going to give me x, y to the power of 0. Because 1 minus 1 is 0. So I have y to the power of 0. And any number to the power of 0 is simply 1. So therefore, partial u, partial y is simply what? X. So I have partial u, partial y as x. But the question says you should find partial z, partial y. So from chain rule, partial z, partial y is simply partial u, partial y, partial z, partial u times partial u, partial y. So notice that partial u times partial u and left with partial z, partial y, which is the question. Okay, so partial z, partial y is now equal to partial z, partial u gave us minus sine u. So I have minus sine u times partial u, partial y gave us simply x, gave us x, 2 times x. So this is actually minus x sine u. But remember that u is simply x, y. That simply now implies that partial z, partial y is now equal to minus x sine x, y. Alright, so I'm going to show you shortcut. Alright, so let's apply the shortcut and see. From z equal to cos xy, we want to find partial z, partial y in this case. Okay, so like I said, partial z, partial y, from the shortcut is this, differentiate the angle with respect to y. So which means the angle is simply xy, remember, the angle is xy. So if I'm differentiating with respect to y, it means I'm going to hold x as constant, then y will change. So if I hold x as constant, and I differentiate y, this is simply 1 times y, this is the power of 1 minus 1. And this will give me x times y to the power 0, which is also what? X. So differentiate the angle partially with respect to y. That means I'm going to have x. So therefore, this is going to give me x Then differentiate the three function itself, cos. If I differentiate cos, I'm going to have minus sine, then put back the arm which is x, y. So that means that partial derivative of c with respect to y is simply minus x sine x y. And that's it. Alright guys, that's it. I'm going to bring another wonderful question on formula method to differentiate partially trigonometric functions. In the meantime, if you're new to the channel, don't forget to subscribe, like and share the videos. Thanks and cheers.